Hello! In this in-class activity, we are first going to briefly review the central limit theorem. Then we are going to apply central place theorem in solving some problems. As you can read from the class reading material, the central limit theorem is very important later on in the study of inferential statistics. In the last in-class activity, we have drawn conclusions that eventually bring upon the central limit theorem. So today, let's first review the major content of the central limit theorem. If all samples of size n are drawn from a population, the population has a mean and variance. 1a. If the population is normal, the theoretical sampling distribution of the sample mean is normal for all sample sizes. We know the theoretical sampling distribution of the sample mean is a distribution when from a population you draw all possible samples of a certain size. And for example, if you draw all samples of size 3 and every time you draw a sample, you calculate the sample mean, you eventually end up have all many different sample means. They're all calculated from samples of size 3. All these sample means of size 3 will form a distribution, and this distribution is called the theoretical sampling distribution of the sample mean. It is called theoretical because it contains all possible sample means of size 3. Now, this 1a says that if the population is normal, this theoretical sampling distribution of the sample mean is also normal. And it does not matter what the sample size is, small or large, they're all normal. So regardless the sample size, as long as the population is normal, the theoretical sampling distribution of the sample mean is also normal. What if the population is not normal? And that is what the 1b says. 1b tries to explain what happens if the population is not normal. If the population is not normal, the theoretical sampling distribution of the sample mean approaches normal as the sample size increases. That is, if you have a non-normal population and if you take all possible samples of size 3 and the sample mean from all these samples will form a theoretical sampling distribution of the sample mean that is not normal because the sample size may be too small. But if you draw all possible samples of size 10 or size 12 and size 20 and size 100 and then forming respective theoretical sampling distribution of the sample mean, and then all these they are going to be more normal than the theoretical sampling distribution of the sample mean formed by samples of size 3. Obviously, the theoretical sampling distributions of the sample mean formed by sample means of size 100 will be a lot more normal than the theoretical sampling distributions of the sample mean formed by sample means of size 10, for example. So that's what the 1b says. Okay. 2, the mean of the theoretical sampling distribution of the sample mean equals the population mean. So this is straightforward. 3a, the variance of the theoretical sampling distribution of the sample mean equals the population variance divided by the sample size. 3b, the standard error of the sample mean, which is also the standard deviation of the sampling distribution of the sample mean, equals the population standard deviation divided by the square root of the sample size. Okay. Now, previously we had a in-class activity where we have a population with only 4 values, 1, 2, 3, 4. This population obviously is a uniform distribution. And from this population, we draw all possible samples of size 2. And these 16 sample means form a theoretical sampling distribution of the sample mean. Also, we draw all possible samples of size 3. And these sample means of size 3, 64 of them, form this theoretical sampling distribution of the sample mean. Now, if you look at this theoretical sampling distribution of the sample mean, this distribution looks more normal than the first one. So this is a very striking phenomena that even though the population is not normal, the theoretical sampling distribution of the sample mean looks a lot more normal, especially when the sample size increases. So that is what the central limit theorem has told us. And also through this in-class activity, we actually seen that. Also from the same in-class activity, we have studied the numerical relationship between the population mean and variance and standard deviation on the one hand, and the mean of the sample means, the variance of the sample means, and the standard error of the sample means on the other hand. We find out that between the population means and the means of sample means, they are identical. Secondly, we also find that for the population variance, if we divided the sample size into the population variance, we can obtain the variance of the sampling distribution of the sample means. In addition, for the population standard deviation, if we divided the square root of sample size into it, we can obtain the standard error of the theoretical sampling distribution of the sample mean. Again, these are the very important conclusions from the central limit theorem, and we actually have used our own calculation to arrive at these conclusions in last in-class activity. Now, let's apply these principles to some simple questions. We have a normal population with a mean 95 and a standard deviation 27. You draw all possible samples of size 12 from the population and calculate the mean for all samples. Question 1. What is the distribution of the sample means called? In other words, what is the name of the distribution formed by all sample means of size 12? It is called the theoretical sampling distribution of the sample mean. Question number 2. What is the shape, normal or not normal, of the distribution mentioned in question number 1? The answer is normal, because according to the central limit theorem, if the population is normal, the theoretical sampling distribution of the sample mean is also normal. Question number 3. What is the value of the mean of the sampling distribution of the sample mean? This value should be 95, because we know that the population mean is 95. And according to the central limit theorem, the population mean equals the mean of the sampling distribution of the sample mean, or the mean of the population equal to the mean of the sample mean. So this conclusion is based upon this statement from the central limit theorem. Question number 4. What is the value of the standard error? The standard error, if you do some calculation, it should be 7.79. How do I calculate this value? According to the central limit theorem, population standard deviation here divided by the square root of sample size, then you put in 27, which is the population standard deviation, divided by the square root of 12. This will give us 27 divided by 3.464, which eventually give us 7.79. Question number 5. If the population is not normal, which of the above answers in 1, 2, 3, and 4 will change? How will they change? Now, we have a population that is not normal. Will the answer in question number 1 change? Question number 1 is about the name of the sampling distribution of the sample mean. Whether a population is normal or not normal, the name of the sampling distribution formed by all sample means will not change. It is always called the theoretical sampling distribution of the sample mean. So answer in number 1 will not change. How about the question number 2? Question number 2 is about the shape of the distribution. And in this case, the answer in question number 2 will change. It changed to is not normal, because according to the central limit theorem, if the population is not normal, the theoretical sampling distribution of the sample mean will also be not normal. So in this case, now in question number 5, we have a population that is not normal. Therefore, the answer in question 2 will change. What about the answers in question number 3? Answer in question number 3 is about the value of the mean of sample mean. And the shape of the population, whether it's normal or not normal, will not affect the fact that the mean of the population will be identical to the mean of the sample mean. So therefore, the answer in question number 3 will not change. And same can be said about the answer in question number 4, which will not change either. Question number 6. For the normal population, Now we go back to a normal population. If the population standard deviation is 19 instead of 27, which of the answers in 1 through 4 will change? And also calculate the changed answer. Now question number 1 is about the names of the sampling distribution of the sample mean. That name will not be affected by the value of the population standard deviation. Therefore, the question number 1, the answer in question number 1 will not change. Question number 2 is about the shape of the distribution. Now we still have a normal population. Therefore, the theoretical sampling distribution of the sample mean is still normal. So answer in question number 2 will not change. And the answer in question number 3 will not change either, because the mean of the population is still 95. And so the mean of the sample mean will still be 95. But the answer in question number 4 will change, since the population standard deviation changed from 27 to 19. So the new answer for the standard error in question number 4 will be 5.48. In this calculation, population standard deviation here changed from 27 to 19, and so new value is 5.48. So this change occurs because this population standard deviation changed. Question number 7, if the population has mean and standard mean 95 and standard deviation 27, goes back to the original question, but you draw all samples of size 50 instead of a size 12. Which of the answers from 1 through 4 will change? And give or calculate the new answers. Now, again, what's new here is the size of sample. Therefore, the only thing that will change is the answer in question number 4. The new standard error is 3.82. This is because the population divided by the square root of sample size in this formula, the numerator does not change, but the denominator changed from square root of 12 changed to square root of 50. That changed the calculation. Eventually, we obtain 3.82 as the standard error. Question number 8. From a non-normal population with mean 95 and standard deviation 27, if you draw all samples of size 12, which answer from 1 through 4 would change? Also, from this non-normal population, if you draw all samples of size 100 rather than 12, which answer from 1 through 4 would change? Let's first look at the situation where we have a sample size 12. A non-normal population with sample size 12. Obviously, the original question has a normal population, and now in question number 8, we change to a non-normal population. Therefore, answers in question number 2 will change from normal to non-normal. Okay, Now let's look at the situation where we have a sample size 100. Sample size 100 with a non-normal population, and compare with the original answers, the answer in question number 2 will change, because now you still have a non-normal population. Okay, so the shape of the theoretical sampling distribution of the sample mean is still not normal. But now, because the sample size is really large compared with sample size 12, so it is not normal, but it's more normal than when the sample size is 12. In addition, the answer in question number 4 will also change. It changed to 2.7 because the population standard deviation divided by the square root of sample size. In this formula, the numbers in the denominator changed from square root of 12 to square root of 100, and that changed the standard error to 2.7. So this in-class activity is about the applications of the central limit theorem. I hope this helps. I see you next time. Goodbye.